All right, ladies and gentlemen, in this video, I'm going to go over how to look at fractions, decimals, and percents when there's shading involved. So here we have a grid, and it's asking what is the fraction, decimal, and percentage of the shaded area. So our job is to figure out what the fraction, decimal, and percent is of this gray part right here. So the first thing that we need to do is we need to figure out how many of these gray boxes are actually shaded. And when you count out all of these boxes, you end up with 15. So there's 15 shaded boxes. The next thing you want to do is see how many total boxes there are. And in here, there are a total of 25 boxes. This is a 5 by 5, so 5 times 5 is 25. So our fraction for this would look like 15 shaded boxes out of a total of 25 boxes. So 15 is the part, 25 is the whole. Now with this, it can be simplified. When I look, they both end in 5, so it's divisible by 5. 5 can go into 15 3 times, and 5 can go into 25 5 times, so we end up with 3/5. So 3/5 of this figure is shaded. Now it does want us to put it in decimal form. You should at this point know that the fifths are a part of your benchmarks. So that means if you had 1/5, each one would be worth 20, so to speak. So if you had 3/5, that would be worth 60, 20, 40, 60. If you don't remember that, you can always do some math off to the side. 3 here, 5 here. 5 can't go into 3. Add your decimals and zeros. 5 can go into 36 times. 5 times 6 is 30. When we subtract, we get 0. So our decimal for this would be 6/10. Our percentage, going from a decimal to percent, all we need to do is move the decimal 2 times to the right. When we move it 2 times to the right, 1, 2, we can attach a 0, and we end up with 60%. For the next problem, we're doing the same thing, except this time they just want to know the decimal. So the first thing you want to do is count how many shaded. 1, 2, 3, 4, and 5. So there are 5 shaded out of a total of 8. Now that might be a little tricky to think about decimal form. So what we can do is, if we wrote it as a fraction, 5/8, we could then convert it, which is technically one of your benchmarks, but if you're still struggling, we can still write it. I'm going to write 5 and 8. 8 can't go into 5, adding decimals and zeros. 8 can go into 56 times. 6 times 8 is 48. When I subtract, I get 2. 8 can't go into 2, add a 0, bring it down. 8 can go into 20 2 times. 8 times 2 gives us 16, and 20 minus 16 is 4. I'm going to add a 0, bring that down, and 8 can go into 45 times. 8 times 5 is 40. And so we can stop there. So our decimal of 5/8 would be 625 thousandths, and that's what the decimal form of this is. For the last one, it says, what is the percentage form of the shaded area? Now I notice I see 1 hole, 2 hole, 3 holes that are completely shaded. So I'm going to kind of start this off with a 3. Then we have this piece right here that's got 2 parts out of a total of 8 pieces, so that would be 2 out of 8. So we have 3 and 2/8, but we definitely need to make sure we put that as a percentage. So let's look at it as a decimal first. That would be 3 point, now 2/8. 2/8 simplifies. 2 can go into 2 once, and 2 can go into 8 4 times. So that gives us 1/4. A quarter is worth 25 cents. So it's 3.25. Now with 3.25, we can't write that as our percentage. We do still have to move the decimal 2 times to the right. So if we move it 2 times to the right, 1, 2, we end up with 325%. One way to kind of think about that also is that you have each whole is worth 100%. So that's 100, 200, 300%. And then if you notice, just a quarter of this graph is being shaded. So that would be a quarter. So 325%.